Hello guys, welcome back. Today we will be looking at empirical distribution function. So what is that and how can we solve it? So let's start with it. What is empirical distribution function? So basically we can also set empirical distribution, we can also write like EDF. So basically this is the way to represent distribution of sample of data. It is a step function that increases by n divided by n at each observed data point, where n is a sample size. The EDF can be used to estimate the cumulative distribution function of the underlying population distribution. To see, here we have to find cumulative relative frequencies, then we can find empirical distribution function. So the first step we will organize the data. We have this data, we will organize it. So how many zeros we have? We have 1, 2, 3, 4. We have 4 zeros. 4 times. And then how many ones we have? So if you look, we have 1 here and 1 here. We have 2 times 1. Then we will look how many times we have 2 here. Okay, 1, 2, 2, 3, 4, 5. We have 5 times. Okay, let's see, 3, then 4, then 5. So 1, 2, 3, 4, 5, 6, 7. 7 times. I forgot about 3. So we have 1, 2, 3, 3 times 3s. And how many times we have? 4, 5, 1, 2, 3. We have 3 times 5. So this organizing of data is called frequencies of each value. Okay, now we calculate the relative frequency. So what is relative frequency? Now we have to calculate relative frequencies. I have also explained this relative frequency before in my previous videos. So relative frequency is total number of values. Oh, sorry. Let me lock this one. Divided by frequency of each value. So how many total number we have? So if we plus all this value like 4, 2, 5, 3, 7, we get 25. So total number of is 25. Let me change the color. So total number of 25 and divided by frequency of each value. So let's see, let's solve this. So we have first 0 here and we got 4 times and divided by 25. Okay, then we go 1, we have 2 times divided by 25. We have 2, 5 times divided by 25, we have 3 times, we will divide by 25, we have 4, 7 times, we will divide by 25, we have 5, 3 times, we will divide by 25. This step is our relative frequency. Okay, now we calculate the cumulative relative frequency. So after this both step, we can find our cumulative relative frequency. Okay, let's go and find cumulative relative frequency. Okay, to calculate the cumulative frequency, you add relative frequency of each value to the sum of relative of all previous values. So if we make a chart, look at for we will first solve this, then make a chart. See, we have 0 here. This is called our data point. Okay, this is our data point. Then we write our frequency. Okay, frequency we have 4. Okay, and to find a cumulative frequency is our 4, and if we look our relative frequency, so basically we have to divide this one. We have to divide and write the answer. It's 0.16, and this one is 0.08, and this one is 0.016, and this one is 3 divided by 25 is equal to 0.12, and if we divide by 7.25, we got 0.28, and here 0.12. So this we can write here 0.16. Let's solve it in other way. To find our cumulative frequency, we say okay, 0 we have 4 times, we divide by 25, we will get 0.16. okay, and cumulative frequency will be same for our first, will be same, and next we will do like this. For 1, we take 4 from above, 4 plus, and this one 2, and divide by 25, and the answer for here is 0.24. okay, now see, our cumulative frequency is different than our relative frequency. Now if we go to 2 and we take 4 plus 2, we take this value down there, and we also carry this 5 here, and then divide by 25. So 11 divided by 25 is equal to 0.44. So technically these values are our cumulative frequencies. Now let's go on third. We take 4 plus 2 plus 5 plus 3. Then if we solve this all, we'll get 14 into 25, and we will get 0.56. And then we go for 4. We again 4 plus, we take this whole value, put here 4 plus 5 plus 3 plus, and the value for 4 we take from here 7, and 7 divided by 25. If we just plus this 14 with 7, we will get 21, and we divide by 25, we will get 0.84. and for the last 5, we take this value, put there 4 plus 2 plus 5 plus 3 plus 7, and we got 5. We got 5 3 times, and we divide it by 25, and we will get 25 by 25, and in the end 1. If you here in the last part, if you get 1, that means the whole above solution is correct. If you don't get 1 here, then there is a problem in your calculation. Let's make a chart. We have here data point, we have frequencies, then we have relative frequencies, then we have cumulative relative frequencies. So we got here 0 1 2 3 4 5, and we got 0. How many times we got 0? We got 0 4 times. We got 1 2 times. 2 we got 5 times. 3 we got 3 times. 4 we got 7 times, and 5 we got 3 times. This number of digits we have in this sequence in data points. Now for the relative frequency, these values are our relative frequency. So let's copy it, and we just paste here. Okay, this one is our relative frequency. And what is our cumulative frequency here? If we write like this, for first we had 0.16, it was the same, then we got 0.24, then we got 0.44, then we got 0.56, then we got 0.84, and in the end we got 1. So this is finish. This is the answer for question 1. For question 1A part. Now we have question number B, to draw an empirical distribution function fx. To solve this, the best way is we will draw y-axis, then we draw z-axis. Okay, we will give number. We have 0 here, 1 here, 2 here, 3 here, 4 here, and 5 here. And for y-axis you have to give these numbers. So y-axis we can write 0 by 10, 0.20, 0.30, 0.40, 0.50, 0.60, 0.80, 0.90, and in the end we get 1. Okay, now we can say here, see, we have here cumulative relative frequency here, and we have here data points. Okay, so for 0 we have value, for 0 we have 0.16, so it will be almost here. So we will draw a line here. Okay, now just remember, in our empirical distribution function graph, we have a common formula. After first line you have to go one place above till second point. So our second point is 24, so 24 can be here, so we go till here, then we draw a line till here. Okay, and then we see for third is 0.44. 0.44 will be here, so you go up directly till here. Okay, and we go till 3 to our next point, and our 3 is 56, so 56 will be here. We go up till here, we go up till here, then we go number 4 till like 4. It should be straight, this line always be straight. Then we have 4 for 56, and 4 we have 84. We go till here 84, then we go 5, and 5 goes directly till 1. That's finished. This is our empirical distribution function. That's all for today. I think you got everything. If you have any question, you can ask me. Thank you guys. Bye bye.